Hi all, welcome to new class. Today's class is about Thevenin's theorem. So far we have discussed about superposition theorem and reciprocity theorem. So next is Thevenin's theorem. Thevenin's theorem states that any circuit having a number of voltage sources, resistances, impedances, and open circuit terminals can be replaced by a simple equivalent circuit consisting of a single voltage source in series with a resistance or impedance where the value of the voltage source is equal to the open circuit voltage across the output terminals and resistance is equal to the resistance seen into the network across the output terminals. So this is the statement of the Thevenin's theorem. So let us study about this Thevenin's theorem in detail, and this is very important theorem in network theorems. So there are some procedures to find the Thevenin's equivalent circuit. So Thevenin's equivalent circuit consists of a single voltage source in series with the resistance, and we have to find that value of voltage source and resistance. So for that there are some procedures. So let us check the procedures to find the Thevenin's equivalent circuit. So these are the steps to find the equivalent Thevenin's circuit. The first step is remove the load resistor RL and find the open circuit voltage VOC across the open circuited load terminals. So first step is remove RL and find the open circuit voltage. Then second one is deactivate the constant sources. For the voltage source, remove it by internal resistance, that is short circuit, and for the current source, delete the source by open circuit. And then find the Thevenin's equivalent resistance, that is Thevenin's resistance of the source side looking through the open circuited load terminals, that is RTH. Then third step is obtain the Thevenin's equivalent circuit by placing RTH in series with VOC. So from the first step we have got VOC, and from the second step RTH. Now place this RTH in series with VOC, and that is the equivalent Thevenin's circuit. Then reconnect the load resistor RL across the load terminals and then find the load current IL is equal to VOC divided by RL plus RTH. That is, here first step we have removed the load resistor. So in the last step connect RL. So after the final step the circuit will be like this. That is, this is VOC and this is RTH and this is the load resistor RL, and we have to find the current IL. So this is the final circuit diagram after applying the Thevenin's theorem. So in this way we are applying the Thevenin's theorem and find the Thevenin's equivalent circuit. Let us do a problem. Obtain Thevenin's equivalent circuit. So this is the given circuit. So we have to find the Thevenin's equivalent circuit. So our first step is to find the open circuit voltage VOC. So for that remove the load resistor RL. So here the load resistor is 24 ohm. So redraw the circuit. So this is 2 ohm and this is 12 ohm, 10 volt. So we have to find the voltage across this open circuited terminals, and that is VOC. So open circuited voltage across these terminals means we have to find the voltage across this resistor. That is across this 12 ohm resistor we have to find the voltage, and that is equal to VOC. So VOC is equal to, that is the voltage across this resistor is equal to, here we have given the voltage source. So total voltage into, that is the voltage division rule. By the voltage division rule, we can find voltage across this resistance. That is total voltage into resistance through that branch divided by total resistance. That is 2 plus 12, that is 14. And that is equal to 8.57 volt. So this is VOC. And in the next step, we have to find RTH. So to find RTH, deactivate the constant sources. So here only voltage source is given. So to deactivate voltage source, we have to short circuit it. So redraw the circuit diagram. So it will be like this. And this is 2 ohm and this is 12 ohm. So now we can find the value of RTH, that is the equivalent resistance. RTH is, here this 2 ohm and 12 ohm are in parallel. By looking through this open circuited terminals, these two resistors are in parallel. So RTH is equal to 2 into 12 divided by 2 plus 12, and that is equal to 1.71 ohm. So this is the value of RTH. So in the next step, that is we can draw the equivalent Thevenin's circuit diagram. So Thevenin's equivalent circuit is VOC. So this is VOC is 8.57 volt in series with RTH 1.71 ohm. Now reconnect the load resistor RL, and here load resistor is 24 ohm. So this is the equivalent Thevenin circuit. Now here we can find the value of current through this circuit. Also, if we want, we can find the value of voltage across this load resistor. So, the current through this circuit is IL is equal to 8.57 divided by total resistance 1.71 plus 24, and that is equal to 0.33 amperes. If we want to find the voltage across this 24 ohm resistor, that is voltage across 24 ohm resistor is current into this 24, that is 0.33 into 24, and that is equal to 7.92 volt. So this is the equivalent Thevenin circuit, and if we want to find the values of current and voltage, we can find like this. So this is about the Thevenin's theorem. So in the next classes, let us do more problems related to this Thevenin's theorem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.